Hey, how's it going, guys? My name's Daniel, aka HashLips, and welcome back to the continuation of our Solidity training tutorials. I hope you've enjoyed it up until this point, and I must say, sometimes Solidity and coding can be rough to understand. But looking at various tutorials and people explaining it, as well as reading the documentation, I am sure that you'll get the hang of it pretty soon. What we are looking at today is the operators. Each coding language has operators that exist inside the framework that can be used to either add to values, subtract from values, work out states, and more. So what we can do today is actually look at a few examples of the operators in Solidity, the basic ones that we will always be using, and that I'm going to explain to you how it works and how to use it. There's a few operators and they are separated in a few different sections. Arithmetic operators, assignment operators, comparison, logical, and conditional operator. We'll be going through these, so create yourself this .sol file, myoperators.sol, create your general smart contract code so that you can get used to doing it, and then create these three variables. I've been using small variable data values, and the reason for that is because we want to stick to the best practices. Seeing that we're not going to be using a big values as these as the A, B, and C values, we can stick with small data types such as uint8, and you now understand what a unsigned integer is. So go ahead and do that. Next, I'm going to start with the arithmetic operators and explain to you how it works. In order for us to nicely work with this code without the IDE throwing errors, we're going to wrap each example inside a function. So I'm going to create a general function and I'm going to call it example. I'm going to call this example1, and in this example1 code, we're just going to make it basically public and open our brackets. These functions are just here to basically explain each example. So I'm going to paste an example on top of each comment, like so. If you remember our comment section in the beginning of this tutorial series, you can go ahead and actually do this like the proper way of commenting, where you can add a declaration like notice and then carry on like that. So maybe we should keep to our standards as well. So let's go and replace our comments, and this one still needs a function. So let's go and add that function. Let's go say this is example 1, this is 2, this is 3, 4, and we're going to have 5. And I just want to space these out correctly. We are not working with an IDE that has automatic formatting, so we do need to do this by hand. But anyway, now we have a function that we can write code in to use these operators. The arithmetic operators work much similar to a calculator, if you can think about it like that. Let's see how we can add A and B, the two variables, together. We can simply say A and use the operator plus B. Now we can even extend it, but let's end our comment over there. We can even extend it and say, well, the A plus B plus C, right? We can do any type of calculation. You can even replace the plus sign with a division or a multiplication sign. In doing this, you are creating a value, basically saying A, which is value 1, times B, which is value 2, plus C, which is value 3. And this will return to you a value. This does not change the state of the variables because it's not assigned yet. For that, we would need an assignment operator. So let's say we had an extra variable here at the top. Call it uint8, and maybe we will call it uint 8 seems fine. I don't think we're going to run over it. But let's call it now new value, right? And new value we're not going to even assign. We just want to have our calculations be assigned to new value when we use the assignment operator. So, like I mentioned, this does not change the state. This simply just uses the state, but it doesn't change it. In order to change state, we need to assign it. For instance, if we were to say this exact same line down here in this example, and our first assignment operator is this equal sign, if we were to put an equal sign right in front of this calculation and then place the new value over there, this is considered as an assignment statement. The reason why I say that is because new value will actually be changed into the output of this and reassigned. You can also reassign a value. For instance, you don't have to stick to now a new value. We can reassign A. We can take this exact same code and reassign it to the variable A. This means that this will execute, update A, and whenever we use A downwards in the code, it will have the updated value. On a side note, because this is not changing state, you can see that there's a warning over here on the left-hand side. If we hover over it, it will tell us that we can tell the function to be a pure view function. A view function is a function that is viewed by the user that does not change the state. That's very important. So we can declare a function as view. It helps the compiler, it helps the source code to read well, and also to compile it a bit differently. Because now we are telling this program that whenever someone calls this example, we're basically just going to do this. We're not even returning values even yet. We will talk about returning values in the functions section. But for now, just understand this is how you can work with arithmetic operators. You can plus, minus, multiply with this, you can divide, you can even use the modulus. So let's check, how do we use modulus values? So now what we can do is we can say, what is A modulus B? Modulus is a very interesting operator. What modulus do is it says, give me the remainder. So it's going to take a 1 and it's going to divide, see how many times 2 can go into 1, and then basically it will give you the remaining value. So maybe A and B is not a good example. Let's rather take C and B. The reason why I'm saying that is because if you take C and you say modulus 2, then the answer should be 1, because 2 can go into 3 once, and then the remaining would be 1, right? Now, yet again, this is not an assignment, this is just an executing calculation. If we were to assign it, we would have to assign it to either a new local variable or an existing variable, or export it, like returning the value. These are just using the operators. This is assigning operators using the equal sign over there. All right. So basically that is modulus. And then lastly, we get these operators, which are basically the double plus and the double minus. How you would use them is you can say A plus plus, or you can say B minus minus. Notice something changes and there's these red lines over there. Why is this red? The reason why it's red is because this changes into an assignment when you use an operator, a arithmetic operator like this. This basically says take A and go and add 1 to A. This one is saying take B and minus 1 to B. So B will end up as 1 and A would end up as 2. But because we are changing state, this no longer can be a view function. So now we can take the view off and everything should be fine. It's good that we go through that process so you can see till what point does these things actually change the state variable, okay? So this is just important to know that this is how you would use these operators. Furthermore, we can go down and we can use these operators much the same way as the plus and the minus. For instance, if we want to reassign B, and remember, if you reassign B, you're going to change the state variable of B. So like I said, whatever we do here, it's going to now affect our next function if we call it after this one, because we already have updated state. So this is just for examples, right? But anyway, if we said B, we want B to have a new value, and we want B to actually be the multiplication of C. So we can say, instead of B is equal to B times C, we can shorten it by saying B is times C. That is exactly the same as this. And that's the only thing I want you guys to understand between the assignment operators and arithmetic operators. Arithmetic operators are basically for just quick addition, subtractions, and actually working with math, where assignments are actually reassigning variables. And you can also do it along with the arithmetic ones like this for easier for an easier way of doing it without typing a whole line out like this. You can just bypass it. All right. Next, we get to the comparison operators. Now, what are comparison operators? These are operators that at the core of itself return a true or a false to the user, or to some condition that you put the code under. For example, if we now declare a new local variable of type bool, we can say, let's call this result. Okay? We're going to say result is going to be equal to false. And see, yet again, we are using an assignment operator. We are equaling our bool, which is our state, not state variable, our local variable now. We are equaling it to false. Perfect. Next, what we want to say is we actually want a conditional. We want to say that our result can change based upon a certain condition that takes place. Now, let's just assume that we haven't changed any of our variables, even though this code will change it if we call the function. But let's assume we haven't changed it and we work off the same values. We can now go and put an if statement, which we'll learn more about after this section. But an if statement basically allows us to do something if a certain condition is found to be true. If you want to create a loop that will always be running and never end, you can just simply add true in here. But it's a very bad thing to do because it means it won't loop forever, but it will always execute this part of the code. The part of the code that it will execute is the part sitting in these two brackets. Again, a small little box. Anyway, let's carry on. Let's take out the true and let's find some conditional. Let's look at our variables here at the top, and we can technically say we want to change the result to true only if variable A is smaller than B. Now, this less than sign is an operator that we can use, and basically what this code is saying here, if A is smaller than B, and how I always remember it is how you do it on school, the arrow goes to the smallest one and the biggest one stays on this side. So you can say if A is smaller than B, then something should happen, and indeed A is smaller than B. A is 1 and B is 2. So this will execute, and we can then reassign result maybe to be true. All right. There is a little bit of a better way of doing this with this last operator, but we'll get to that. Anyway, because we are now comparing and we are actually creating local variables, we probably have to now restrict this to a view function again, because we're not changing anything in the local state. So we can make this function view because none of these are actually changing our local state. We are just simply working with, our state variables. We are not changing state variables. We are creating a local variable, but that's still seen as a view function because we're not changing state variables. We're not changing stuff that the blockchain needs to save, basically. Next, we can still say, but what if we don't only want to check if A is less than B, but what if A is less or equal, like less and equal to B, meaning that A can be 1 and it will still return true because B is 2. But if A is 2 and B is 2, it will also execute this block of code. The reason for that is because we are saying it should be smaller and, smaller or, it was right, it should be smaller or equal to B. And if A is 2 and B is 2, it is still equal and it will still execute this code. As soon as A becomes 3, that's when this code will be skipped, this block will not execute, and the result will stay false. Alright, these are just little examples. Next, we get cool operators that we can also use where we can say that if A is equal to B. Now, when you equal and check an operator's equal, you put 2 equal signs. In some programming languages, you even use 3 equal signs, such as this, but we don't use that in Solidity. Then, if A is equal to B, and only if A is equal to B, we will execute this part of the code. The next section that I want you to have a look at, or the next operator, is this exclamation mark. Now, what the exclamation mark is saying is exactly the opposite of the equal sign. The exclamation mark and the equal sign basically says, as long as A is not equal to B, then execute this block. So if A is not equal to B, this will execute, which is indeed the case. A is 1 and B is 2, which they are not equal, and this will execute. A is currently not equal to B, so this will never execute. So that is just one thing I want you to understand, and that's basically all for the comparison operators. I know this explanation might seem a bit weird where I just talk about it and then start typing. But trust me, in doing this and following along and thinking about what I'm telling you guys, and when we get to the project part where we're actually going to start writing out projects and I talk to you about these things, they will click in your head and you will immediately know what I'm referring to. Let's carry on and look at this logical operator. Now, in the logical operators, we have the exclamation mark, which we've seen before. That usually just means not, right? And we have the double, this and sign, and we have these 2 lines. What does this mean? Well, these logical operators allows us to actually combine a lot of these things. I'm going to copy this part of the code and put it in here. I'm then going to go ahead and say that, well, we want to know if A is less than B. But what if we also want to know if C is greater than B? So we can say that A should be less than B, and the and sign is these double and signs. We want B to be greater than C as well. If you have these in a condition with an and statement in between, the program is going to run and is going to check this first. If this fails the condition and is false, it will not bother to go and check the rest because it knows that it needs to both be true. If this one is true, it's going to check the next one, and if that is true as well, that and then only then it will execute this function. Going on, we can get really creative. If we copy this and paste it, we can actually get very hectic with these statements because you can append them, you can have another and another and conditions in between. So we can also say, well, if we have A is less than B and B should be greater than C, but A should be equal to, I don't know, or equal to A. I don't even know if that's possible technically because, or C, because of these conditionals. So let's just say that A should be greater than 20, right? So we can even put full-on integers in there as well. Now, this is how complex these things can get and how your logic can get. It's usually a good practice to keep this logic small, solid, and explanatory. It's also a good idea to not just use A and B's as variable names. Use more descriptors variable names, because that way, if you read the code, it kind of reads like a book. Now, let's look at one more example where we actually have a Boolean example where we can say that if we create one Boolean up here, so let's create a bool and call it my bool, and we are going to initialize this to false, like so. This is a state variable, remember, and let's say we want to check this Boolean against our result, for instance. Okay, we can say that if our result, okay, is equal to our my bool at the top, we can check these two as well. And if it's equal to that or not equal to that, then basically it's going to fail, right? But this will fall more underneath this example over here. And I'll show the example that I wanted to just now. So I'm going to copy it and put it here. Yeah, that definitely falls more in that section. But in the case where you want to use the not, what you can do is you can say, well, if my bool is not, and the is not part is this little section over here, the exclamation mark, basically just says that if the Boolean is not true, right? If this is not true, meaning that my bool, if it's not, meaning that if it's false, then it's going to run. Now, this will then run because that's false. But if the Boolean, for instance, was true to begin with, and we check this conditional, then this shouldn't run because we are checking that if the Boolean is not, meaning, you know, if it's falsy, or if it's not the correct value or the right value, right? The yes, not the no, basically. So it's the inverse of something. And how you can use that in code is very interesting. You don't always have to check it like that. What you can use this for is to actually assign something. So you can actually assign a switch in code, what we call it. So we can say that the result is going to be false, okay? And the false over there is now always false, but let's say we want to reassign result and we want to assign it to the opposite of what it currently is. We can say that we want to assign it to be not result, meaning that if it's now false, it will reassign it as true. So it goes the same for this one, right? So if this started off as true, like so, and we call this one in here, remember, if statements will only run if it's true. So if this starts off at true and is not true, meaning that it goes false, then it won't run, okay? But in that case, if this was false and we said that it is not, so meaning that it is false, it will run, right? Because then it gives the inverse. But anyway, that's how it works. Lastly, and also we get a warning, meaning that we are busy changing some kind of state because we are using this my bool right here at the top when we kind of changing it in a way, I guess. So we need to now create this. Oh, we're not changing it. Sorry, we're not changing it at all. And that's why we get to call it a view. Don't let me confuse you guys. All right. Next up, we have our last operator example. And this is the conditional operator. Now let's just for a second imagine that we had a bool, okay, a Boolean value over here. And we are also going to have this as result. And we want to equal the result based on a condition that A is greater or less than B, okay? We want to say if A is, let's say we wanted to actually create a number value, not a Boolean, because that won't make sense. So we're going to say integer 8, and we are going to say if A is less than B, okay? This is kind of asking a question, and in these conditionals we always have two parts. We have a question mark, which is going to ask this question, and then we're going to have the value if this question or this statement is true. So if this is true, we want to return to the result a number 100. If it's not true, we're going to put the colon and we are going to return maybe 50. We're going to end the statement just to make sure that everything will work. And this is seen as a ternary operator in JavaScript, but basically how you use it is you have a condition which checks and asks a question, hence the question mark. It then decides to return a value based on a true or a false value being returned. And yes, we can then also make this view because nothing is being changed in the actual state variables that we have up there. But it's also learning, and it wants us to do what? It says result unused variable. Oh, because we're not really using this variable. So I guess we can just leave it like that. We're not going to build the contract, but I am going to comment it out so that we don't have to sit with contracts that don't build. Later on, we'll see how we use the variables and export them, such as returning them from a function. But for now, this is just an example. Before I forget and get a bunch of comments in the comment section, I forgot to explain what these two lines are. That's called the OR statement. Now, the OR statement is quite unique and special, and you will also use that quite a lot. You define it by putting two straight lines. I don't know what you call that key, but you define it like that. The OR statement basically means that this condition on the left or this condition can be true for the program to run this piece of code inside. Like I said, when we get to the if statement parts, right after this video, you'll understand if statements a lot better. I just wanted to explain the operators so long using if statements. So if this doesn't make sense yet, don't worry, we will get there. Lastly, I see that there's a warning. So all I want to do is basically cut this stuff out, right? I want to just declare my variable first, and then after declaring my variable, I want to say the result is equal to that. All right? And there should only be one equal sign, and that will get rid of this warning sign. And the reason for that is because we are just declaring it and then we are assigning to it. That is all for today, guys, and I really hope that this made sense. I also want to advise you, as always, to go and check out the Solidity documentation on whatever we are talking about. But if you followed along and you kind of understand, that's a very good sign, because it means that when we get to creating smart contracts, when we get to create real use cases in the world, and I talk through what we are busy creating, you will exactly understand what we are doing, and you will own Solidity by the end of this course. Thank you so much, and see you in the next video.